Okay, in this example, we're going to be stating the vertex, axis of symmetry, and y-intercept for this function. Now, it's important to note that this function is in standard form. There's no parentheses. It's been distributed out. So we can't use transformations on this. Instead, for the vertex and axis of symmetry, we're going to have to use the equation for the axis of symmetry, which is x equals negative b over 2a. In a quadratic, typically a is the coefficient of x squared, b is the coefficient of x, and c is the number by itself, the constant term. So in this case, a is going to be 1 because there is no coefficient there, so it's implied to be 1, and b is going to be negative 6. I will then substitute them into the equation, giving me x equals negative b, which is negative 6, over 2 times a, which is 1. And then simplifying this, the double negative makes a positive 6 on top. So we have 6 over 2 times 1, which is 2. So x equals 3 is the equation for the axis of symmetry. Now for the vertex, vertex and axis of symmetry are related because the axis of symmetry goes straight through the vertex. So they share the same x value, which means for the vertex, we already know that the x value is 3. To find the y value, we can simply plug in our x value 3 and get the result of that. So we're going to plug it into our equation, replacing x with 3, and then simplifying this, giving me negative 4. So our y value for the vertex is negative 4. So the vertex is an ordered pair, 3, negative 4. And lastly, for the y-intercept, we would replace x with 0. However, since this is in standard form, the y-intercept is just going to be the constant term because everything else is going to cancel out. If there is no constant term, it would be 0. But there is a constant term, so in this case, the y-intercept is just 5.